Before we begin the tutorial, if you're interested in engineering simulations, coding tutorials, and more, be sure to hit the subscribe button and turn on notifications. Also, feel free to drop any questions or thoughts in the comments below. I'm always excited to hear from you. Now let's begin. With the blank model open, click on Library Browser icon. Scroll down to Simscape. Click on Simscape, click on Power System, click on Specialized Technology. Open Fundamental Blocks. Add Power Gate to the model. Under the Fundamental Blocks, open Electrical Sources. Add DC voltage source to the model. Open Elements. Add Series RLC branch to the model. Open Measurement. Add current measurements to the model. Scroll down and add the voltage measurements to the model. Open Power Electronics. Add the diode to the model. Scroll down and add the MOSFET to the model. Close the library. Separate the components. Now let's set up the circuit. Connect the positive of the voltage source to the drain of the MOSFET. Open the properties of the MOSFET and unclick Show Measurement Port. Apply and close. Open properties of the Series RLC branch. Change the branch type to L. Apply and close. Rotate the inductor. Connect one port of the inductor to the source of the MOSFET. Now rotate the diode, making the cathode face the MOSFET. Open the properties of the diode, unclick Show Measurement Port, apply and close. Connect the cathode of the diode to the junction where the MOSFET and inductor meet. Duplicate the inductor. Open the properties of the duplicated inductor. Change the branch type to C. Apply and close. Connect one port of the capacitor to the anode of the diode. Duplicate the capacitor. Open properties of the duplicated capacitor, and change branch type to R. Apply and close. Connect one port of the resistor to the junction where the capacitor and the diode meet. Connect the other port of the resistor to the negative of the voltage source. Connect the inductor and the capacitor to the negative of the voltage source. Now the circuit is complete. Open the properties of the voltage source and change the amplitude to 20. Apply and close. Open the properties of the inductor and change the inductance to 150E-6. Apply and close. Open properties of the capacitor, change the capacitance to 220E-6. Apply and close. Take the current measurement, delete the connection between the voltage source and the drain of the MOSFET, and connect the current measurement in between. Connect the current measurement positive to the voltage and the negative to the drain of the MOSFET. Take the voltage measurement, connect its positive to the positive of the voltage source, and likewise the negative of the voltage measurement to the negative of the voltage source. Duplicate the current measurement. Delete the connection from the capacitor-diode junction to the resistor. Connect the current measurement to the resistor and to the capacitor junction. Duplicate the voltage measurement. Connect voltage measurements to the resistor. Now we have two voltage measurements connected to the source and the resistor, and two current measurement connected from the input voltage source to the MOSFET and from the capacitor junction to the resistor. Now double tap on the screen. Add constant block by typing constant and selecting the constant option on the screen. Add the go-to tag to the model. Connect the go-to tag to the first current measurement. Open the go-to tag properties and add a name. Let's call it IN. This is a tag name. Apply and close. Duplicate the go-to tag. Connect it to the voltage measurement of the voltage source and change the tag name to VIN. Apply and close. Duplicate the go-to tag. Connect it to the second current measurement. The tag name is IOUT. Now duplicate this tag, connect it to the voltage measurement at the resistor, and change the tag name to VOUT. From the back of the output voltage measurement, go to Tag. Using the blue arrow, draw out a form tag. The blue arrow will draw out a form tag belonging to the go-to tag. Now add the add block to the model. Open the add block properties. Let the sign be the plus and minus. Apply and close. Now connect the constant, the form tag. Connect the voltage tag to the negative of the add block and the constant to the positive of the add block. Now add a PID controller. Connect the output of the add block to the PID controller. Open the properties of the PID controller. Go to the controller and change it to pi. Change the integral to 0.1. Apply changes. Open the PID Advance. Click on Limit Output. Change the upper saturation limit to 0.8 and the lower saturation limit to 0. Apply and close. Now open the library browser. Open the control measurements. Open the pulse and signal generator. Add the PWM generator DC-DC component to the model, and close your library. Connect the output of the PID controller to the PWM generator. Open the properties of the PWM generator. Change the switching frequency to 25,000. Apply changes and close. Add a go-to tag to the model. Connect the go-to tag to the output of the PWM generator. Open the go-to tag properties and change the tag name to SW. Apply and close. Drag out the from tag of the SW go-to tag, and connect the from tag to the gate of the MOSFET. Now add the scope. For the number of inputs, type 4. Drag the from tag from the voltage measurements at the voltage source, and connect it to the first port of the scope. Drag the from tag from the current measurements at the input, and connect it to the second port of the scope. Drag the from tag from the voltage measurement at the output, and connect it to the third port of the scope. And lastly, drag the from tag from the current measurement at the output, and connect it to the scope. Double tap on the first form tag and type V in beneath the line. For the second from tag, type I in. Click on the line of the third voltage tag, and type V out. Click on the line of the last current measurement tag and type I out. This method is very optional. Open the scope, under View, click on Layout, and select 4 box layouts. Close the scope, change the time to 0.1 as the time of simulation. Open the constant block properties. Change the number to 30 and apply. Add the display block to the model. Connect the display block to the output of the PID, the controller. Open the scope, click on the play button to start simulation. So, from the result output, we can see that the input voltage is 20 volts, and the output voltage is larger than 20 volts, is between -25 to 27 or 28 volts. For this simulation, the circuit is working as a boost converter, and the duty cycle is 0.8. So, let's make it work as a buck converter. Let's change the name of the PID controller to the duty cycle. To change the duty cycle, open the PID controller properties, go to the PID Advanced. Change the upper saturation limit to 0.25. Apply and OK. Open the scope and restart the simulation. We can see from the waveform that the output voltage has reduced. It has reduced below the input voltage. With input voltage 20 volts, the output voltage is now -5 volts, because the duty cycle has been reduced to 0.25. Now let's change the saturation limit back to 0.8 and apply changes. Thanks for watching. If you found this tutorial helpful, don't forget to like this video, share it with others who might benefit, and subscribe to the channel for more content like this. I'd love your feedback or any questions you have in the comments. Let's keep the conversation going. See you in the next video.